Okay, so this is going to be the lab explanation for the gas lab. So at station 1, you have two bottles that are filled with water, and each of them have a Cartesian diver in them. So what you want to do first is notice the level of air in the Cartesian diver. Kind of look at the little smile and tell where the water or where the gas level is. Then you're going to squeeze this really hard, and when you do that, the diver should dive. And now when it's down there, look and see what the air level is, so that you can tell, say at the beginning the air level was this, and then at the end it changed to this. So that's the point at table 1. Then you're going to go to table 2, which is going to be a table that you will really enjoy. And you're going to put about 3 to 5 milliliters of water, which you can get out of the sink, and you're going to put it in your pop can. Then you're going to put your pop can on the heater, and you're going to wait. And you're going to wait, and you're going to wait until steam is really pouring out. Not the first second that you see steam, but after steam's been coming out for a few seconds. Then what you do is you grab the beaker tongs, and you hold them with your palm side up. You grab the can, and you tip the can over and plunge it into the ice water and see what happens. And then you put the can in the basket that we have over here to collect the cans, and then be careful because the burners get very hot. Okay, table 3. You've got a few things going on at table 3. So at table 3, you have a Petri dish with a liquid in it underneath this plastic container. You're going to take the beaker, fill it about halfway with water, put a couple of drops of A in the beaker, then quickly lift this container and put this on the paper towel next to the Petri dish, and then just wait and see what happens. Okay, once you've seen the reaction, you take the beaker out, dump the water out, rinse it, and put it back for the next group. And then you have one more thing that you're doing at this station, and you're just going to follow the directions with the syringe. So what you're going to do is you're going to take the handle out of the syringe. Okay, this one isn't working very well. You put a miniature marshmallow in there, and then you just follow the directions. So you're going to be putting your thumb over the end and pushing this in a little bit, pulling it out. And so when you're done, throw away your marshmallow. Be very careful that you don't try to push the marshmallow right through the end of the syringe, because then it's very hard to clean for the next group. So the other thing is, don't eat any of the marshmallows because everybody's been touching them. Okay, over here, table 4. You're going to be looking at the relationship between pressure and temperature. So this setup right here is going to have water in this bucket at room temperature. This one over here is going to be on a heating unit. So again, the heating unit's going to get hot, so be careful. The water in this beaker is going to be boiling, so you can read the temperature off of the thermometer, but it's going to be very hot. And then this one over here, we have dry ice in, so this one's going to be very, very cold. So you're going to record the temperature of each of these 3 spots, and then this is the instrument that you use to measure temperature. So it's important that you use the same piece of equipment for all 3 of them. So you can't use this one here and this one over here. So you want to use the same one for all 3. And usually you start over here with room temperature. You just put it in so that the ball is below the surface, and you record the pressure on this gauge. When you're done, you take it out, you can tap it on the paper towel or on the beach towel, and then you put it in the boiling water. And then you read the pressure, take it out, tap it, and then put it into the very, very cold water and see how the pressure is changing with the different temperatures. Okay, so now I'm going all the way over here to table 5. The important thing about table 5 is not to scream. So what you're going to do here is you're going to take an acid tablet out of this container, and you're going to break it in half. You're going to take this little vial, fill it about halfway with water, put in the half a tablet, put the top on really tight, put it down, and then just wait. After a while, the gas is going to build up and the top is going to pop out. So you don't want to scream when it pops out. When it pops out, or wait, you put the antacid in the water, you step back and you start counting. And you count how long it takes for the top to pop off. When it pops off, empty it out, rinse it out, and think about a variable that you want to change. Do you want to add more water, less antacid? The only thing that you can't change is the amount of, you can't increase the amount of antacid because then it costs too much to do this lab station. So the most you can put in this container is a half a tablet. When you're done at this station, it gets a little messy. Make sure you clean up so that the next group doesn't have to clean up a mess before they can start. Okay, over here, table 6. Table 6 is another one that you're going to really like. First thing you're going to do is light your candle. So the candles are stuck in the beaker, so just light the candle, and then you're going to put a scoop of baking soda in the Erlenmeyer flask, and then it says to add 25 milliliters of vinegar. So you're going to measure out 25 milliliters of vinegar, add it, it's going to bubble up, and then it's going to start to bubble down. When it starts to bubble down, you pick this up and you pour the gas at the bottom of the candle, or at the bottom of the base of the flame. And the gas should put out the flame. If you dump your vinegar on top of the candle, it will go out, but it won't go out because you use the gas to put it out. So you just want to hold it sideways and let the gas that's in the Erlenmeyer flask flow out and put out your candle. When you're done here, there's a big mess, clean it up. All right, over here, table 7. You're going to plug these in. You keep them unplugged because they get really, really hot. So when you go to use this, you just plug it in, and then you be careful because this is going to get hot. So when you plug it in, now we've got 2 deflated balloons. You might recognize them from the density lab way back in the fall. We saved them. What you're going to do is you're going to hold the balloon above the heat. If you put it here, the balloon's going to break and we're not going to be very happy with you because nobody else can now do this station. So you want to hold it up here and see what happens to the gas that's inside of this balloon. Once you've seen what happens, you take it away from the heat, unplug it, and kind of see what happens when you take it out of the heat. Now, also at this station, in this bucket, will be a couple balloons that have an odor. These are all kitchen odors. They're flavorings that you can add in your candy making or baking. So there's nothing nasty smelling. They should all be good smells. And you just try to identify the smell that's in each balloon. Then on your lab sheet, write the green balloon smelled like, the yellow balloon smelled like, so that you can tell us what you smelled in each of the balloons. And then there's one more station. The last station is back here on this table. And what you're going to do is you're going to take a balloon out of the bag and you're going to blow it up because that stretches it out a little bit. Then you're going to put the balloon in the 2-liter bottle and you're going to use a straw to blow up the balloon, but you're not going to put your mouth on the straw. So think about that. Try to figure out how you want to do that. You're going to try a couple different things until you can figure it out. When you're done, because you've already used this balloon, you're going to throw it away. And the straw, because you didn't put it in your mouth, you can leave there for the next group. And that is the pre-lab for the gas lab.